Hey, good morning. Just an update for you. It's been a number of years since I made the video series on how to make a 72-inch by 2-inch belt grinder. And I have to admit, in the intervening years, this machine has been indispensable in my shop. I don't know how to even say it. You can't overstate how handy this thing is, or I can't. I use it almost every time I come out to the shop for whatever reason. It is just such a useful tool. So a friend of mine that has a shop wanted me to make one for him. So I did. And I'm going to show you how I did it with the measurements, and then we're going to show you the finished product. Oh, and by the way, just to let you know, if you see an advertisement here on YouTube on my channel, I don't get anything for it. I don't know what YouTube or what Google puts on my channel or on the videos as you're watching them. I have nothing to do with that. I don't get any money, just to let you know. A little disclaimer there. Okay, so let's get started. We'll start at the bottom and work our way up for the components. There's the base. It's a piece of 8-inch channel, 18 inches long. And I've got a 2-horsepower motor, 5/8 inch shaft. A bit overkill, as the motor that I have on my grinder right now is 3/4 horse, but I got it really cheap. I got 2 motors, $10 each. It was a print shop that was going out of business. These were on the shelf, and the guy didn't know if the motors worked or not, so I was able to get a really good deal on them. Basically bought them for scrap. If they worked, fine. If they didn't, I was out 20 bucks. So I got them both working. They're both a little bit gummed up from all the ink that was on them. It was an old newspaper place, but I was able to get them up and running. So that's the power and that's the base. So next I'm going to talk about this little unit here, this die-cast pulley that is unobtainium right now. You can't buy one. We'll talk about that here next. Chicago Die Casting got bought out a couple years ago by another company. And as such, they stopped making some of the products. And one of the products they stopped making was that crown pulley that's on the motor right now on my original grinder. So what do? You have to make one. So here's what I came up with. Using the same Schedule 80 pipe that I had for the wheels, I cut another chunk, and this one here is 2.5 inches wide. And you can see it's got a crown on it. I went ahead and crowned it a little bit. It doesn't take much, about a 1/16 from straight on each side. So what I did was I figured I had to make a center. I didn't know how to do that, but instead I figured if I could get a steel pulley, I could go ahead and put it in there, tack weld it in place, and then use that instead. Usually a motor pulley is cast iron, and cast iron doesn't weld worth a darn. So trying to find a steel pulley was a little bit of an issue. They are out there, but I found this one on eBay. True Run Steel Pulley by Gates. They don't make them anymore, but you can get them on eBay. 2.5 inches outside diameter, bore 5/8, which is exactly what I've got for my motor. And you can see it's got a keyway in there, and it's got a set screw, which I already drilled a hole for. I inset this 3/4 of an inch on this side, on the back side, and since this is steel, I was able to weld it, tack weld it in place, and it's a nice press fit. The inside diameter of this is less than 2.5 inches, so I had to take and put it on my lathe and go ahead and turn the inside of that piece of tubing so that pulley would just press fit in place. And I'm pretty happy with the result. It looks like it's going to work out really nicely. Pretty happy with that. Okay, now we're moving on to the 3 pulleys that we have, 2 for the face and 1 for the tensioner. I found a little problem here. I cut off one little section of that Schedule 80 pipe, cleaned it up on the inside, got that ridge out on my lathe thinking that I was going to have a press fit on the bearings, and the bearing just dropped right on through.
I don't know why. Maybe Subaru changed the diameters of the pulleys a little bit in the intervening years. These pulleys, I went to my local Subaru repair place and they had these in the trash. I went ahead and made sure to tell the owner that I'm using them for a tool and not going to put them back into an automotive application. So what to do? I was like, okay, this is no good anymore because I already cleaned that out and made it bigger, thinking that I was going to have to press fit them like the original one. So this one was the closest. This is the tensioner pulley on the cam belt in the Subaru, and this had a little bit of a play, not much. I was able to take 3 blades out of my feeler gauge, 2/1000 feeler gauge, and put 3 of them in here to space it evenly. And I went ahead and I tack welded it. Tack welded a couple places in here, and it spins really true. And before I did that, of course, I had to make sure to crown this a little bit like I did on the original one. These were a little bit more problematic. These are the drive belts for the cam, or the drive for the cams with the cam belt. They were quite a bit bigger than the inside diameter, or smaller than the inside diameter of the pipe. So I didn't know what to do. I could have welded everything up and then turned it and everything, and that would have been just way too much work. So I did the same trick I did with this, except I took 4 blades out of my feeler gauges. And I've got a bunch of feeler gauges for whatever reason I've collected over the years. And I used the 5/1000 blades and put 4 in here, 2 on each side and then 90 degrees, 2 on that side. So then I went ahead and once the feeler gauges were in place and I made sure that this is nice and level with the back side of this pulley, I went ahead and just tacked it in place. And then I took it over to my existing grinder and bolted in place and spun it just to make sure it spun true. One of them I didn't do a very good job, and it had a little bit of a wobble to it as it was spinning. Yeah, of course not that much, but a little bit of a wobble. So I had to cut all the little spot welds I had out of there, little tack welds with a Dremel tool and the cutoff wheel. Tried it again. I was successful the second time around, and I was really happy with the result. It spins true. Same thing with this one here. This is the other one. And these do not have a crown on it, just to let you know. Okay, moving on to the next bit. Okay, moving forward on the grinder. This is the vertical tube that comes up. The other one gets welded onto the side here. It's pretty heavy. 2-inch square tubing, 1/4 inch wall. It's 13 inches long. And that's really about it. Nothing special about it. Just cleaned it up a little bit. You can see, I hope you can see the writing on here. This tubing is pretty rusty. Most of the stuff came out of my scrap pile, not all of it. So the next part is the tensioner that slides in. This is made out of 1.5-inch square tubing, 3/16 wall, and this is 16 inches long. And if you look at it, it has one slot that's milled here from one end to the other, and also this side of the tubing and this side of the tubing I've milled flat. Reason why is trying to get it to slide into this tube and do it smoothly. Usually you can't do that because the little seam that's in here, you can see, I don't know if you can see it or not. There we go. Maybe you can see it. It's got that seam there. It's hard to grind it all the way back in through there, and I don't know if I'd want to try to do that or not. So an easy solution to that is just to put a groove in here. I went ahead and just used my mill, put a ball end on it, and milled a channel in there. You can do the same thing with a 4.5-inch angle grinder using a wheel, a grinding wheel, and just grind a V groove in there. It'll do just the same. So the other thing I did to make it go in and out smoothly was I milled these 2 faces flat. Just a little bit. The tubing kind of gets pinched a little bit If you look at it from the end when it gets manufactured, and there's a little bit of a bulge here on each side. And even if you milled that groove in to the top to make it slide into the tubing, it still won't fit because it's just a little bit too tight. So I went ahead and milled this flat. One side would fit, the other side wouldn't. You can do the same thing with a flapper wheel on a 4.5 inch angle grinder. You don't need a mill. You can just make sure this is nice and flat. Once you got the groove cut, you can take and try to slide it in. If it doesn't work, polish off a little bit more and keep on working it till you get to the end. Now we'll get to the business end here on where the adjustment wheel is. Okay, I said adjustment wheel, actually tracking wheel, that's on the top right there. One thing I forgot to mention, that this gets a little plate welded over it, a little like 1/8 inch plate, just so the spring here has a place to push up against. And just to let you know where these springs came from, is a compression spring, Century Spring Corporation, and it's a C832. Sorry, I ripped the ID when I pulled the bag open, but C382, if you look at it, they're 1 inch diameter, 0.120 diameter spring, and they're long, and I just tacked them together, and that's what I used. That's what's going to provide the tension. This goes like so. Spring drops in there, and then with that plate on the bottom, that will just right up and down with tension. Okay, this is the little adjustment arm that comes up with the idler wheel on it. Idler wheel has a little carriage bolt like this. I already went and filed that round hole into a square, and then let's see if I can make this happen. Nope. We'll put this like this. There we go. So that's how that fits. A few washers underneath, but that's the tracking mechanism for the top of the belt grinder. So I didn't do any markings on this because all the action happens with this thing. I got another piece of 2 inch square tubing like this, 2 inch. It's a 1/4 inch wall, and I took out the seam that was on the back side of it and just left it square. So what I did was I used this basically as a drill guide for everything, to match drill pretty much the whole assembly up on top. So the it's 3 1/8 inches long. You can go to 3. I don't know where I get 3 1/8. I think maybe that was just the length of chunk that I had left over. So I cut that out. If you look at this hole, it's a 3/8 hole. It's over from this edge 1 1/16 inches over this way, and then down this way it's 5/8 of an inch. So I marked that, slid this over the top of both of them, made sure it was even with the end, and I went ahead and just pilot drilled that all the way through, and that's what gave a really nice true bore for that. This one here, this hole, it's 2.5 inches down from the top. So with that lined up, I was able to put a bolt in here once I got the hole drilled, and then I drilled from this side, I think from this side all the way through, and then ended up with a match drilled basically hole for this as well. So once that hole was drilled, I took my square file, made it to where the carriage bolt would fit in there, and since this, I know this looks kind of weird, since this flops up against here with the carriage bolt in it, you have to have clearance for that carriage bolt head. So that's what I did. I just made a big hole. I got my step bit, put a 7/8 inch hole right here, and the adjustment will come in from the back side, get a nut welded on here. Now, what I should have done is probably flipped it around and did it the other way. So my nut for the adjustment is not welded with this channel, but it really doesn't matter. I mean, it's just an aesthetics thing. Functionality, it doesn't affect it whatsoever. Okay, let's move on to something else here. This is the part that's the horizontal that's going to be welded on. And let's take a look at the measurements on this. 2-inch square tubing, 1/4 inch wall, 8 inches long. This 3/8 inch hole is 1 inch in from the end. And on this one, I was able to take my little air grinder and I cleaned up that ridge on the inside so the tubing would slide in there nicely. And this is also 1.5 inch square tubing, 3/16 wall, 14 inches long. And this one here, same thing, hole 1 inch from the middle. If you look, this slides in without too much fuss. Why this one went in and the other one didn't, I don't know. This was newer tubing. If you look at it, it's not the old rusty stuff I had here. So maybe that was different, little difference in manufacturing, but it slid in just really nice and it'll be nice and tight. Okay, so once that is in place, this piece of 1/4 inch plate for a spacer, that hole is just from, that's just a scrap plate. I didn't make this hole. Scrap plate is 2 inches wide by 5 5/8 inches long, 1/4 inch plate, just another scrap piece. That gets welded on to here. And then once that is on there, then this piece goes on, and that's where the idler pulleys go on. Okay, just as a bit of a refresher, here's what I'm talking about here. This is that 1/4 inch plate that's 5 5/8 inches long. And then also this is the setup that I have with the Platen for the pulley. So now I got a good picture of what's going on here. This is that same piece, but it's not welded on. This all gets put on like so. So what's this here? We got 2.5 inch angle, 3/16 thick, and this is 13 inches long for that. You can tell it's already been sculpted. This is the other part of the angle, comes out. This is 6 inches long. This is cut off 2.5 inches from the end, and then of course this is radiused a bit, so it makes it look nice. And then this, like I said, this is 6 inches long, and it's the same width, 2.5 inches wide. Now what I did was I welded on an angle brace. The other one on the grinder that I have, I noticed after I used it a while, this was not stable enough. I added this piece of angle and I bolted it onto the original version because this one here flopped around a little bit. It vibrated. So that piece of angle stiffened it up quite a bit. So what is that? So it's 1.5 inch angle, 3/16 thick, 7 inches long. And you put an equal distance between this hole and this hole. Okay, the holes that are drilled in here, they are 1 11/16 in from the edge if you have the angle without the edge being cut. That's the distance. 1 11/16 inch center, same over here, 1 11/16 center over here. So the spacing on these, if you look at it, between the two, 10.5 inches. So basically you just divide it in half, right in the middle of the 13 inch piece, which would be, what, 6.5 inches? Split the difference, 10.5, 10.5, or I'm sorry, 5 1/4, 5 1/4, 10.5 total. And that's what you get for where to drill the holes for the axles for both of those pulleys. And you can see I put this cutout here on the original version. I wondered about leaving it off this time to get a little strength. But you know, when I'm using it, I actually use it sometimes when I put parts around this little side. I'll make the belt and I'll track it to where it's right on the edge, and then that way I've got just a little bit where I can go just a little bit beyond the 90 to clean up the inside of a corner or something. This little notch has come in really handy. So you can build it how you want, but I would recommend leaving that little notch in there, or putting that notch in there. So here's the original rest that I had made. I had some square tubing, and then I put some 1/8 inch plate on each side to kind of make up the difference between this. Cut a groove with an angle grinder for the slot here. I'm doing it a little bit different this time. This time I thought about it. I thought, why would I go about messing with just getting a couple of plates when I can just use a piece of angle, and that's what I did. I took 1 inch square piece of tubing, 1/8 inch wall, 6 inches long, and then if you look at it, I tacked another piece of angle to one side of it. The angle is 1 inch, 1 inch angle, 1/8 inch thick, and again 6 inches long. And I milled a little slot again for the in here for the seam for the tubing, so it slides in nicely, and it's nice and tight. I like that. So when I weld it all together, I'll be able to put the rest on, and it'll be nice and 90-degree angle to the platen. And that's the last part that we're going to talk about here before we go on to assembly. It's a 2 inch angle, 3/16 inch thick, 4 inches wide, a little bit cut off on the end here, and that's what's going to get welded on to that 1 inch piece of tubing, and that's just going to make for a rest when you're grinding on some parts. So let's start getting towards assembly. Okay, what a difference a couple of days make, and a little bit of activity on the welder. So this is what I ended up with all the bits and pieces that were on the previous segment here. So this is the 8 inch channel that I welded all the pieces onto. You can see that got the spring in there, ready to go. And I have some of the nuts welded on too for the adjustment nuts that I've got. Okay, so let's start with the base. Again, 18 inches, 8 inch channel, and welded the 13 inch piece up here, and then the other piece over here. Put a little stand on it. I wanted to support it just a little bit. This weld down here, it's pretty sturdy. I couldn't imagine this bending. However, I thought it'd look kind of cool if I put a little strut there and put some lightning holes in there. This thing weighs a ton, so that's not going to matter much. When you do weld this tower on there, you need to make sure that this is on the vertical to this flat surface, whatever it's sitting in. This has a little bit of a crown to it. You can feel it when you put your hand over it, and also if you put a straight edge on it, it walks back and forth. So this is not going to be, if you put it flat, it's going to be tilted a little bit off towards the outside. So what you want to do when you weld it, you want to make sure that it is at a 90-degree angle to the table or to your work surface, not to this. Make sure that that is the case, because that's going to be your basic alignment. So this tower is welded 10 1/4 inches from this end over here to this face. Why 10 1/4, you might ask? Well, when you put it all together, we need to make sure that the loop of the 72-inch belt has got enough tension from the spring, but not too much tension to where it's going to really mess up the motor. How do we do that? Or why? I'll show you why that works, or how that works. So this is the Platen. You saw all the bits and pieces for it before. So now you can see it all together. This is that 2 inch by, I think, 5 5/8 piece. I'm not sure, 3/8, 5/8 piece of of a 1/4" plate. That's the spacer. Makes up all the difference of all the stacks of all the different materials here. The platen lies flat. The wheels don't touch the bottom surface, but they do spin free and they're very close to the bottom here. And then also you can see the angle iron that I had put on there previously as a stiffener. Okay, so let's go ahead and put this in here and show you why we're looking for that spacing on the motor. I'll pause it here for a second. I'll put the motor up because it's pretty heavy. I got the motor in place just about where it's supposed to be. I moved it side to side a little bit just to see where it's going to fall. I wanted to make sure that this drive pulley was engaged fully on the end of the motor shaft. It wasn't inside the pulley that I welded in there. So I got that lined pretty well. You got a little bit of a gap, not too much right here, and it can move in and out just a tiny bit. There's still a little bit of adjustment here. I drilled these holes for mounting the motor right in the middle of these elongated slots that they have at the motor base. And this is the measurement that I was talking about. Get my tape measure here. Get from the pulley over here to this pulley here, 22 inches. Right on that end to right on that face. And that'll give you the correct loop for the belt that goes around here up to the tensioner and all that. And it won't give you too much tension to burn out the bearings in the motor, but it'll also give you enough tension so it's not going to slip very much or at all. So there you go. That's what that's the main structure there. One other thing I wanted to point out, you have this little rest we talked about. I took great pains to make sure when I welded it, I had a very square block from my machine shop stuff and laid it up here, put this on here, and tacked it all together. It's really important if you want to really make accurate grinding, I guess, you won't lack better terms, for 90-degree angles, and it helps a lot. It's almost like having a little mini machine shop. And I got a little square, and you put it up there, and it's right at 90. So that's going to really help out quite a bit when you're making some parts, making sure that the face is 90 degrees to the base. So there it is. Now we got to put on a lick of paint and see if the thing runs. Okay, so the project's done. So here's the final result, the Mark II version of my belt grinder. Doesn't look a whole lot different than the other one. The only differences you could see probably is that I have this strut up here, and the other one was using a old trailer hitch part. But all in all, it runs really nice. I'm really happy with the result. A couple changes that I've made. I painted this rest yellow because that rest comes in and out all the time depending on what you're grinding on. It's easy to lose track in the shop when everything is gray and metal looking, so I painted that yellow. And also, since it's going into a shop with a bunch of other people potentially working on the machine, it's always kind of bugged me that this thing doesn't have any guards on it. It's basically just spinning out there and just have to be careful. So at least to feel better about it, I went ahead and put this paddle switch on. Turn it on. It runs nice and smooth. And then to shut it off, we just hit the paddle. It's all gone. Okay, so moral of the story, if you don't have a belt grinder, 72 by 72 inch belt grinder, I encourage you to make one or buy one. It has got to be one of the best tools, one of the handiest tools that I have in my shop. I use it all the time, and I think if you ever built one, you won't be disappointed. Anyway, thanks for watching, and good luck in your build. See you soon.